DKWP, 小工阿伯. Your learning journey starts now. Ever felt like AI is a magic box? You feed it stuff, and bam, answers pop out. But why? That's the million-dollar question, or rather, the multi-billion parameter question. We need to crack this black box, and that's where the DIKWP model comes in. Think of it as our X-ray for AI minds. First up, OpenAI. They're like minimalist architects for AI brains. Their trick? Sparse transformers. Imagine a super dense network suddenly forced to be sparsely connected. Most connections vanish. What pops up? Tiny, clear circuits for simple tasks. Think matching quotes. Suddenly, you can see exactly which neurons are detecting the quote, classifying it, and finding its match. It's like watching a tiny, logical robot inside. This shines a light on the data and information layers, showing how raw inputs become specific knowledge. But here's the catch. It's mostly about simple stuff. For complex wisdom or hidden intent, it's still a bit foggy. And yes, making it sparse makes it simpler to understand, but sometimes less powerful. Unless you make it huge, then maybe both can coexist. Next, Anthropic. They're like detectives, using tools called sparse autoencoders to untangle the messy signals inside neurons. Think of it like separating a tangled bundle of wires. They found thousands of features in GPT-2, each tied to a single concept, like recognizing DNA sequences or Arabic script. Suddenly, the model's internal knowledge isn't just a blur, it's a map. This gives us great insight into the information and knowledge layers. But they didn't stop there. They even tracked intent. They found features linked to Claude being overly agreeable, sycophancy, and could even manipulate Claude into writing scam emails by tweaking these internal switches. That's touching the wisdom and purpose layers, seeing not just what Claude knows, but what it might be trying to do. The catch? It's painstaking work, especially on massive models like Claude. Finally, DeepMind. They're sharing the love with Gemma, a smaller, open-source model family, and GemmaScope, a toolkit to dissect them. They used those same sparse autoencoders, but applied them layer by layer across the entire model. What did they find? Millions of features, showing how the model evolves from basic facts early layers to more complex reasoning later layers. It's like watching a thought bubble grow from simple ideas to sophisticated judgments. This is fantastic for understanding the flow from data, through information knowledge, towards wisdom. Plus, they explicitly mention using this to spot safety issues, like when the model starts making things up or ignoring rules. The big win here is openness and scale, letting everyone play detective on a transparent platform. So, what's the grand takeaway? These methods, viewed through the DIKWP lens, show us pathways. We can now better trace how raw data becomes meaningful information, how that builds into structured knowledge, and even glimpse the sparks of reasoning and potential intent. Think of it like mapping an AI's cognitive journey. There's always a trade-off. Making it easier to understand might slightly reduce its raw power, or digging deep takes immense effort. But the future? Maybe we'll build AI that's inherently more transparent, designed with explainability baked right in from the get-go. Thanks for tuning in.